fearsome power of a very cruel sea.
There is something out at sea, terrorizing the world shipping.
Out of the darkness came this great wall of water. I've never seen a wave as big as this in my whole life.
It can strike out of the blue with devastating consequences.
You hit solid water and it is like running into a brick wall. The entire bridge was wrecked.
Horrific. Monstrous. You feel as if the end of the world has come.
This is the story of a wave that is sinking ships around the world. A killer that defies all scientific understanding and that no ship is designed to withstand. It is one of the best-kept secrets of the sea that once a week a ship sinks to the bottom of the ocean, often without mayday or any clue as to what happened. One of the most mysterious of these disappearances is that of the München. The München was a vast new type of cargo ship. The length of 2.5 football pitches, she was the pride of the German merchant navy. On the 7th of December 1978, she set sail on a routine trip to America. On board were 27 crew, including Uwe Hinrich.
This was my son, Uwe, 20 years old. He liked going to sea. He said it was the safest ship in the world. Everybody said it was unsinkable, the best ship in the world.
That night in December, there was a giant storm raging across the Atlantic. The waves were the size of houses. But that would not have troubled the München. For a ship so powerful and well-maintained, such storms were just routine. It was assumed that all was well and going to schedule. Until 3 a.m. on the night of the 12th of December. It was an SOS from the München. She was in trouble and needed help. But at this stage, no one was too alarmed, because even if damaged, the powerful München could float for days.
At the beginning, we were very calm. I told myself this couldn't happen to the München. It's so safe. Everything had been taken care of. They'd thought about everything.
Within hours, search and rescue planes were sent to find her, and all the ships in the busy shipping route came to join in the search. Like a police hunt, they were lined up 3 miles apart, combing vast areas of the ocean for the München. It was the biggest search in the history of shipping. In charge was Captain Peter de Nijsch.
We hoped to find the ship, or at least people, or a lifeboat, a life raft with people, and we never found any living soul, which every day became more disappointing.
All that was recovered was an empty lifeboat and some wreckage.
That a ship can be in trouble, that can happen to any ship. It happens all the time, everywhere now and then. but that it completely disappeared. That such a big modern ship could disappear. That was surprising.
For some reason, the great ship and her crew had disappeared off the face of the earth, and no one could understand why. An investigation started immediately, going over every detail of her design and the few remains that had been found. The only clue to what happened was found on the recovered lifeboat. Normally, it hung 20 meters above the waterline, and it was one of the tiny metal pins that it hung from that drew the investigators' attention. One of them was Werner Hummel.
The key, actually, to what could have happened to the München is the forward block of the starboard lifeboat, which is shown here on this picture. We see here on the pictures these steel pins bent from forward to aft. This indicates that the boat hanging underneath was struck by a tremendous force from forward aft, which caused these bendings of these rather strong steel pins.
Some huge force had hurled the lifeboat out of its metal pins, 20 meters up above sea level. But what this force was a mystery. The Maritime Court could only conclude that bad weather caused an unusual event, which led to the sinking of the ship. But many mariners suspected they knew what sank the München. Something that, according to legend, sinks a huge number of ships every year. A freak wave. The freak, or rogue wave, is one of the great myths of the sea.
All my sea career, I've been hearing stories about rogue waves.
Mariners talk of a single breaking wave the size of a tower block that can rear up out of nowhere.
It was colossal.
At least 80 feet high, probably even bigger.
We estimate the height of the wave 30 meters.
It looked enormous. It looked like a white cliff.
It was just like a mountain, a wall of water coming against us.
I've never seen a wave as big as this in my whole life.
It's not a tsunami or tidal wave. It's not caused by earthquakes or giant landslides. No one knows where it comes from or why it happens.
The freak wave is a huge, steep wave coming out of the blue without any prediction, without any expectations. It's just that.
But there's one small problem with all these stories. According to all scientific knowledge of the sea, freak waves are practically impossible. Scientists have understood ocean waves for centuries. They are simply made by the wind. The stronger the wind and the longer it blows, the bigger the waves. In order to predict the biggest wave a ship will meet, scientists use a set of mathematical equations called the linear model. This says that in any sea condition, there is a limit to how big the largest wave will be, and that mariners' tales of monster waves that come out of nowhere have got to be wrong.
Mariners are like fishermen, aren't they? I mean, they come back from the sea and they tell all kinds of interesting stories, and people look at them suspiciously.
It's sort of like, you know, the fish that got away, and he says, oh, that was 10 meters long, you know. Well, waves are sort of the same.
Jim Gunson of the Met Office uses the linear model to explain why freak waves shouldn't exist.
Using the linear model for a given sea state, this bell-shaped graph gives the probability of a certain wave height. And it's like in a population of children in a class. There is an average height of children, and most children are around that height. Some are quite a bit taller or shorter. There's the chance that a child is 3 or 4 times the height of the average child is very, very small.
So, according to the linear model, even in a fierce storm where average wave height may be 12 meters, the chance of meeting a 30-meter wall of water is practically zero.
Using the linear model for a 12-meter sea state, the chance of finding a 30-meter trough-to-crest wave height is 10 to the minus 5, which is 0.00001. To put it in perspective, a wave like that would come along using the linear model once every 10,000 years.
The linear model is so well accepted that the entire multi-billion-pound shipping industry relies on it. Meteorologists use it to predict wave height, and naval architects to calculate ship strength. And the biggest wave used in ship design is just 15 meters. The idea that there might be freak waves out there seemed impossible. Instead, any mysterious disappearances at sea have been blamed on far likelier culprits, like corrosion and human error. But then one day, something happened that forced scientists to look again at their ideas about ocean waves. On New Year's Day 1995, a storm was brewing in the North Sea. The Draupner oil rig was 100 miles out in the harshest of weather. The sensors were regularly reading waves of 12 meters. When suddenly, out of the blue, came a wave that was so high and so steep, scientists had thought it was impossible.
For me, it changed everything. Really changed everything. This wave is at 26 meters. It's so much bigger than the background sea state.
When the New Year's Day wave came along, which fits this picture, a 30-meter crest to trough height in a 12-meter sea state, alarm bells started going off because of the very low probability of this wave. Yet we saw it.
The sensors measured a wave so steep and so high it should only occur once in every 10,000 years. Suddenly, it seemed that the mariners might be right after all. The New Year wave shocked wave experts. Among them, Julian Wolfram. He has spent years since then studying the same part of the North Sea, looking for more freak waves.
What we need to do is to study waves like this, because we need to know how frequently they occur, because if they occur quite frequently, they could actually pose a serious danger to offshore structures and ships.
Wolfram was looking for any waves that were bigger than the linear model would predict, and to measure them, he installed a radar device, looking down to the sea surface.
We have a device which faces down to the surface of the sea and basically sends out an electric pulse, hits the surface of the water and comes back again. And we time the amount of time it takes to go down and come back. And from that we can estimate the distance from the radar to the wave. And we do that continuously, so we actually get the profile of the surface.
Over 4 years, Wolfram measured every large wave that hit the platform. And when he plotted the size of these waves compared to the height of the waves around them, he found something completely unexpected. The linear model predicts that when you plot the height of individual waves relative to the waves either side, they should all lie on a straight line. And when the average size of the waves was small, the linear model held true. But he found 24 waves that veered well above the line. These biggest waves occurred far more frequently than the linear model predicted. It appeared that these 24 waves were a completely different sort of beast.
Well, one of the things we learned when we plotted out the graph was that in fact the really extreme waves are different from the slightly smaller waves. They have different characteristics. They tend to be significantly steeper. They also tend to be higher than we would normally expect based on the ordinary theories we've used up to date. They are unusual. They are freak waves.
It seemed Wolfram really had found the rogue waves of Mariner's myth. For the shipping, if there really were freak waves out there, then potentially billions of dollars were at risk. It could mean having to redesign every single ship. With so much at stake, scientists needed to understand what was going on. Where did freak waves come from, and was there any way of predicting them? Searching for clues, they looked at where mariners had reported seeing freak waves and found one place where they seemed to happen over and over again. South Africa. The southern Cape of Africa is a major shipping route, with millions of tons of cargo being shifted every year. The seas here may look calm, but for years they have been notorious to sailors for the ferocity of their waves. Captain Di Davis is one of the leading salvage experts in South Africa. He's seen the damage these waves can cause dozens of times.
The Neptune Sapphire was a brand new vessel on a maiden voyage. It was as if a cutting torch had cut the ship in half, completely. Atlas Pride happened in horrific weather. This big wave just came out of nowhere, hit the bow and destroyed the whole bow. Mimosa was a very big vessel. The ship's side plating was punched in, completely smashed in, causing a hole to be formed you could fit 3 double-decker buses into. When I went aboard the ship to carry out the salvage, the captain, who was a very experienced Norwegian master, said it's the biggest wave he'd ever seen in his life, he'd ever seen.
Since 1990, 20 ships have been devastated by rogue waves off the coast of South Africa. Scientists like Martin Grundling decided to find out what was going on in these waters to make them so dangerous. So they plotted the locations of all the accidents on a chart. And when they laid this over an infrared image of the ocean, they noticed a very striking pattern. All the points lay along the same strong ocean current. The Agulhas Current.
These crosses that we plotted of all the accidents that occurred off the South African coast, they're all located in this red band, and this band signifies the Agulhas Current, which is a major current flowing down the South African coast. It originates in the Indian Ocean, so it's warmer water and therefore visible on this infrared image.
The Agulhas Current is a huge ocean current of warm water streaming down from the north. On its own, it shouldn't cause freak waves, but scientists suspected that if the current heading one way were to meet wind and waves coming in the opposite direction, then perhaps this could be the source of all the trouble.
Down here in the south is the area where all our waves and storms are generated, deep in the Southern Ocean. And they propagate in a northeasterly direction up like this. And this is the area then where the Agulhas Current coming from the northeast meet up with these wave and swell conditions coming from this area down here. So this is really the danger area in terms of these two significant phenomena.
But it was only when Grundling got access to a new type of satellite, one using radar, that he could actually measure the height of waves in the current. And it was just as Grundling had thought. When the waves were going with the current, they were small. But when the waves were going in the opposite direction to the current, the effect was dramatic.
What we have here is a plot of the wave height outside the current and the wave height inside the current. And what is quite conspicuous here is this very, very significant increase in the wave height as the satellite moved across the current.
When the waves had to fight the current, they grew massive. The current pushed against them, driving them so high and steep, a monster would rear up. Here, it seemed, was a simple explanation for the mythical freak.
These things are not really what used to be called freak waves. They're not of a freakish nature, but they're quite common. They will occur every time that there are waves moving against the current, and that happens very, very often.
This simple explanation was a godsend for the shipping industry. It meant the huge waves were easy to avoid. Just steer around the Agulhas Current. There was no need to spend huge sums redesigning the world's fleet. And when scientists looked at other places where freak waves were most often reported, like Norway, straightforward local conditions were again found to be the cause. Ships were simply ordered to follow a different route and avoid the danger areas. There was now no need to question science's understanding of the sea. And it seemed that the freak wave mystery had been solved. But then something happened last year in the South Atlantic that no one could explain away, and which would shatter all the simple explanations. In February 2001, the Caledonian Star spent several weeks cruising around the Antarctic. On board were 105 British and American tourists enjoying the wonders of the Southern Ocean. The Caledonian Star is as strong as almost any ship in the world. specially built to cope with the ice and harsh conditions. So when they received a bad weather report for the journey home, no one on board was worried.
We had a weather forecast predicting gale force winds.
It's a very common weather report. The ship is expected to face that sort of weather all the time.
That didn't bother us at all.
The storm worsened until the waves were over 12 meters high. The ship rode these easily, and still no one was concerned. Until 5:30 p.m. on the 2nd of March, when the first officer saw something unexpected.
Out of nowhere, I saw in the distance, about a mile away, a wave that appeared to be twice the height of the average wave height.
We estimate the height of the wave 30 meters, which is extremely high.
It was just like a mountain, a wall of water coming against us. And it came from a different direction, like 30 degrees on the starboard bow.
As the wall of water approached, they saw a huge trough open up before it.
The ship probably went down at an angle like this, and more or less like a free fall, because the waves are moving very fast. And when the ship is tipping, she fell like this. And talking to the other people on board the ship, they were all falling against the bulkheads in the forward part of the section, wherever they were. So she went like this, directly hitting a wave, and just buried the bow into the wave. The helmsman, he was standing here, and he actually took cover. And when he looked down, he could not see the crest of the wave.
You had a wall of water ahead of you, and the ship was just running into that wall.
The whole bridge was like an explosion. And I was washed like I was blown away by a water jet over to the other side. Me and the helmsman were lying on top of each other, underwater, fighting books and cushions and charts. And I had to swim, actually I had to swim and crawl to get back to the controls to be able to put the ship back on course.
The effect of the wave was devastating, shattering the ship's instrumentation. The ship was effectively blind.
We lost our radars, the gyro compasses, the echo sounders, the sonar, parts of the radio communication.
It was a very humbling experience. Of course, it went through your mind that this might be it. We might not make it.
But the Caledonian Star was lucky. Her engines were still working. The crew boarded up the windows, and eventually the ship limped back to port. But another ship out at sea at that time was less fortunate. The Bremen was a German cruise liner. Again, she was built to withstand anything the South Atlantic could throw at her. On board were 137 tourists. They too were hit by a giant 30-meter wave, which devastated the bridge.
The bridge wasn't operable. All the nautical tools, instruments, the whole electronics failed immediately with the break-in of seawater. Everything, including radar equipment, weather faxes, ventilator, alarms, everything malfunctioned. All the instruments short-circuited, the steering gear failed completely. The ship was in distress, not maneuverable.
But unlike the Caledonian Star, the Bremen also lost her engines. The ship and all on board were now in desperate trouble. Unable to power her way through the sea, the ship drifted side-on to the waves, exposing her weakest parts.
When the engine failed, the ship lay transversely to the sea, and the sea rolled crossways to the ship against the big windows of the restaurant.
This was the worst situation possible. The restaurant windows are extremely weak. If they were hit by any large wave, water would flood in and the ship would sink.
We would have capsized. It would have broken through or smashed the windows.
It was now a race against time. To turn the ship away from the waves, they desperately needed to restart the engine. But the starter generator was in pieces on the floor. If they couldn't start the engine, the ship and everyone on her was doomed.
We came from the Antarctic and had nearly 0-degree water temperature, and the air temperature was the same. In those high sea conditions, it wouldn't have been possible to put lifeboats or life jackets or life rafts in the water. As well as that, the passengers we sail with aren't the youngest anymore. I doubt any of us would have survived.
So, in dark, rolling seas, they set to repairing the engine. All the time, the waves were smashing against the windows. And then they got lucky. The engine finally started.
Then for the first time, I had hope we would make it. They are wonderful moments when you know everything works normally again.
Both the Caledonian Star and the Bremen were fortunate to survive. But their experiences challenged everything known about freak waves. There are no currents or local conditions to cause rogue waves in the South Atlantic. According to traditional theory, such waves should be incredibly rare. Yet here were two, within days of each other. So what was going on? Science mobilized every technology to solve the mystery. Using a new radar satellite, Susanne Lehner of the German Aerospace Center began searching for freak waves around the globe.
Now, with these radar images, you can really see the individual waves. You can see wave lengths, wave directions, wave grouping.
The European Remote Sensing Satellite travels across the ocean using highly sensitive radar to get a detailed picture of the sea surface. It can pick out individual rogue waves from anywhere in the world.
What we get is an image like this one. This is actually the radar image with the highest wave we found on all of our 30,000 images we analyzed. This is a 30-meter wave here, the high crest followed by a very low trough.
This is exactly the size of wave which hit the Bremen and the Caledonian Star. The sort of wave that science said was practically impossible. And in just 3 weeks' worth of data, they found over 10 such huge waves out in the deep ocean.
What you can see here is this highest wave we found of about 30 meters, that is color-coded in red. The next highest waves here are about 27-meter high waves, color-coded in orange. We find another high wave here in the North Pacific, This is again a kind of 26-meter high wave here. We did not expect to find in this limited amount of time so many of these extreme wave events.
If the satellite data is right, it looks as if freak waves occur in the deep ocean far more frequently than the traditional linear model would predict. The question is, why? The answer seems to lie in a completely different branch of science. Al Osborne inhabits a strange mathematical world where almost anything can happen. It's the bizarre non-linear world of quantum physics. In this world, objects appear and disappear according to one remarkable equation, the Schrödinger equation.
The Schrödinger equation, quantum mechanics. We have TV programs called Quantum Leap and so on and so forth. So we all think we know something about that equation. There's a version, however, modified, that describes deep water waves.
Osborne is one of the world's leading wave mathematicians. For 30 years, he has been obsessed with the theoretical waves described by the Schrödinger equation. The equation describes a theoretical water surface where huge waves can suddenly leap up out of nowhere, where for some reason normal waves become unstable and grow huge.
The physics of the nonlinear Schrödinger equation we can see in this simple example. In the beginning, it doesn't seem like there's anything happening, and we could all just give up and go drink a beer if we wanted. On the other hand, we could keep moving forward and maybe something will happen. What we'll see is this central wave here is going to start to grow. It's growing because it's robbing energy from its two nearest neighbors. So here it's starting to come up. You see it's growing. It's stealing energy from the nearest neighbors. And these waves are starting to drop. See how this is coming down here? Look at that decrease. And now, in its full glory, it's a very large wave. It has two smaller waves on each side and two rather deep holes in the sea around the peak.
In Osborne's theoretical world, these non-linear waves could grow into monsters. But the idea of waves becoming unstable like this in the real world was so outlandish that oceanographers said it could never happen.
If you talk to people who know something about ocean waves, nobody was going to take this theory seriously.
Until someone sent him the profile of a wave. It was the one that hit the Draupner oil rig in 1995. The New Year wave.
For me, it changed everything. Really changed everything.
The New Year wave looked identical to one of his theoretical, non-linear waves.
I was flabbergasted. Absolutely flabbergasted. It just looked exactly like one of these exotic solutions to the nonlinear Schrödinger equation. One of the ones that we threw away over the last 30 years because we said, this kind of thing can't happen. This kind of thing is just too strange. Yet, it just sits there and it looks at you, and you have to entertain the possibility that it is a real effect. And it might really have something to do with these extreme waves in the ocean.
If Osborne is right, here is the reason why rogue waves occur in the deep ocean. It isn't to do with strange local conditions. It's because waves start to behave in a bizarre, non-linear fashion. For some reason, they become unstable and start sucking up energy from waves around them.
You have what's called a rogue sea. Now, mariners have known about this. You look at the sea state in one moment, everything just looks random, boring waves that we've known about for a long time. But then, one of these waves will come up. They're all there. They're all hiding away. One of them will come up. Then a little later, another will come up. But in between, you won't see them necessarily.
Osborne's theory means that there are two types of wave: the ordinary stable linear wave and an unstable nonlinear monster. A wave that at any point can turn into a rogue.
It says that there are really two kinds of waves. Amazing thing. Not the old boring sine waves that we've known about for 2 centuries. Not only those, but there's another kind of wave. It's a really special beast. It hides below the background waves and then comes up every once in a while.
This could then explain what Wolfram saw in the North Sea. It could explain what caused the waves that hit the Bremen and the Caledonian Star. And it could explain what caused the large number of waves observed by satellite. It seems that there is a separate population of waves out in the ocean that are higher and more frequent than anyone had thought possible. And there's something that makes these waves especially deadly. It's not just their size, it's their shape. The linear model used by the shipping industry has always assumed that waves are smooth and gently sloping. So ships are only designed to cope with undulating waves like these. But according to mariners, freak waves are very different.
It was a vertical wall. It wasn't a sloping wave. It was a vertical wall of solid green water.
I likened it to the White Cliffs of Dover. It just looked as though there was this enormous great cliff ahead of us.
Freak waves aren't the smooth, undulating waves ships are designed for. They are so steep, they can actually break. It means they can hit a ship with astonishing force.
The reason why rogue waves are so damaging is because they're breaking. It's no longer really a wave. It's just a pile of water coming flying at you, and it just goes bang.
Engineer Rod Rainey analyzes ship damage for the marine industry. He has been calculating the huge forces that these giant breaking waves have on ships compared to normal waves.
This ball here represents the force of a 3-meter classical linear wave hitting a ship. That's the force of about 1.5 tons a square meter. This represents a typical storm wave, say 12 meters high, hitting a ship. About 6 tons a square meter. And this represents a force from a rogue wave. That's about 100 tons a square meter.
This force is far greater than most ships are designed to withstand.
We've looked very carefully at ships that have been damaged by breaking waves, and we are sure that the pressures that you can get over substantial areas are about 100 tons a square meter. Now, that compares with what a ship is normally designed for, high up on the side, which is typically about 15. Now, just to be clear here, that 15 tons per square meter is what it can take without any damage at all. It can take perhaps double that if you allow it to dent, but it can't take 100 tons a square meter. That will hold it.
It seems that rogue waves are not only out there, but they are far more powerful than any ship can handle. All the scientific evidence suggests that the old explanation for why the shipping industry loses a ship a week may be inadequate. It may not be just corrosion or pilot error. Some, at least, must be due to freak waves. It means that at last we can lay to rest some of those mysterious disappearances at sea, like that of the München. As the storm grew on that fateful night in December 1978, the München would have carried confidently on, carving through the rising seas. Until suddenly, out of the darkness, there would have loomed a huge 30-meter wall of water.
The way it most probably goes is that the bow of the vessel is diving into a trough, a wave trough. And then before it has raised up again, the wave is, so to say, collapsing over the bow and the superstructure, and with tremendous force striking against the front bulkhead, hitting the starboard lifeboat and doing the damage which we have seen on the picture.
The wave would have smashed into the bridge, just like it did in the Bremen. Taking out the instruments and engines and rendering the ship helpless. If the ship had turned side on to the waves, another wave could have hurled her. Water would have poured in, eventually plunging the great ship München and everyone on her to the bottom of the sea.
Next week, Horizon looks at one of the most epic journeys ever made. Could it be that 17,000 years before Columbus, Stone Age people crossed the Atlantic Ocean to find America?
Now you can get 8 BBC channels, including world cinema and exclusive drama.
You can already get these new BBC channels with others on cable and satellite, but now you can also get them on Freeview, a new package of 30 channels.
You can get Freeview by plugging an adapter into your TV. It costs around £99, one-off payment, no contract.
Television, it's evolving.
For your free guide, call 08700 10 10 10.
Dead Ringers is an award-winning Radio 4 comedy that celebrates those special people who bring meaning to our lives.
People misunderstand me. They think that the only thing that Russell Crowe's about is stealing other men's wives and brawling at award ceremonies, which is nonsense. Because I'm quite happy stealing other men's fiancés and brawling in the street as well. Don't mess with me, Sunbeam.
Imitation is the sincerest form of mockery. Dead Ringers starts Monday at 9 on BBC Two.
That was Roxanne by The Police, or as they're now known, Sting. Song there about a prostitute. Doesn't say what her surname is. Must give her a call sometime.
Oh! That's English for stop a horse.
Alan's back on his feet. The new series continues Monday at 10 on BBC Two.
So close you can almost smell them now on BBC Two. Expect strong language from the entertainers.
Yes? Come on. Oh, you're so fat. Look at that.
That's gross.
Isn't he fat? Oh, steady, 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 steady.
Is that
Lovely
your pet?
colour.
Is that your new pet?
Yeah, it's my little pet, my little friend. It's a yellow-bellied toad.
What's his name?
I haven't named him yet.
Toadie. Go on, take him into some dinner.
He's probably very scared. Oh, fuck!
So we're going to have to dress up smart, Bernard, aren't we?
The body beautiful. Look at that. Charles Atlas.
It's like you've got... No, there's no suntan.
No, no. White I was born, white I will stay.
So you don't mind getting dressed up for the old races then, Bernard?
Not at all. No, nice collar and tie now and again. Show the flag. Yes. When you drive a rolls, you can dress as you want, you know.
Is that right?
You go out dressed as a tramp.
I'm amazed you're not going out in your pants.
Oh no. Get arrested. You know me. Don't give a fuck.
Right. All right. Love you. All right. Well done. King of the jungle.
Hi, Tony.
Hello there. Hi, Ellen.
How are you doing?
Fine. Thanks for the champagne.
You're now like one of
Thank
the
you.
most famous people in Britain.
King of the jungle.
That's great. And in here, Tony, thank you.
Thanks. Did you get my text?
Yes, thanks so
You
much
got
for
it?
that. Yeah.
Yeah, thanks a lot. Thanks very much. Pleasure.
Hello, Bern.
You tinker, hiding round the corner.
How you doing, mate? All right?
Come on.
Good to see you.
Welcome to Derbyshire. You'll be all right. Get in here.
Okay, mate. I like your hat.
Thanks for bringing it. Hey, what does it say there?
Hey, look at that. Grand Prix Monaco.
Yeah, I got it from Rotherham last weekend. Car boot sale.
Were you ever sort of a rock and roll entertainer?
Oh,
Your time?
what do you mean was? I still am.
No, I mean rock and roll in the sense of abusing your body.
Oh, here we go. I knew we'd get around to this sooner or later. He creeps these little questions in, have you noticed? Very little, very cunningly. Have you ever sort of abused your body? What kind of a programme is this, anyway?
I think I got a silly crown on the top of this.